Hi everyone, in this video we're going to talk about 1.4 complex numbers. The three goals we're trying to reach by the end of this session is to simplify complex numbers, add and subtract complex numbers, and also multiply and divide complex numbers. Okay, let's take a look at these two basic examples. We know that if we take a square root of a number, actually a square root of a perfect square, this is going to be 3. And that's because we know 3 squared is 9. Here we have square root of -9. This here, if you try putting this into your calculator, it won't work. Your calculator can't take square roots of negative numbers. So to kind of like go around that and bypass that, we rewrite this as square root of 9 times square root of -1. And what happens is square root of 9, we know that's 3. But what square root of -1 is, we call that an imaginary number because it doesn't really apply in the real number world, and that becomes I. So we equate square roots of -1 as I. So let's take a look at what are these I's, otherwise known as imaginary numbers or complex numbers. So imaginary number is a number, when we square it, give us another negative number. So again, it's not a real number, so it can't be graphed on the number line. However, imaginary numbers actually have real applications and are used in applied math, physics, electronics, and engineering. Okay, so just let's formalize what imaginary numbers are again. It's defined as I, which is equivalent to square root of -1. And let's say, well, what if we square that? What does that give us? Well, if you square I, it's like taking the square root of -1, and that's equal to -1 because the square root is canceled by the exponent 2. So when you have I squared, it's equal to -1. This is important because you're going to actually use this equivalence again and again in simplifying square roots of complex numbers. Okay, so example 2, let's try taking the square root of -80. 80 is not a perfect square, right? There's no number that will multiply by itself will give us 80. If it were square root of -81, that would be a different story. That would be 9i. But square root of -80, we have to break it down. So let's break it down to square root of 80. And of course, we're going to break it to square root of 80 and then square root of -1. We know this is I, so we can change that. The square root of 80, let's break that up into square root of 4 and square root of 20. You may wonder why we're picking these two numbers, because 80 has a bunch of factors. And the reason why we're breaking it up into 4 and 20 is because we want a perfect square, like square root of 4. So if we did 80 and then did 8 and 10 instead, 8 is not a perfect square and neither is 10. So we pull it so that factor it so that one of them is also a perfect square. So we know square root of 4 is 2. Square root of 20, we can break it one more time into square root of 4 again and square root of 5. Remember, this is all multiplication. You have to just know that. And then 2, it's times square root of 4 is 2 again, square root of 5, and then I. These two numbers, now because they're out of the root, we can multiply 2 times 2, get 4. Square root of 5 stays under the root. And this I, we could put it at the end, but usually instead of putting it at the end, because we don't want, sometimes we get confused as I under or out of the root. So we just write the 4 before the square root for I square root of 5. Okay, let's take a look. Oh, and I'll also show you a shortcut. So same problem, square root of -80, and we break it up into 80 and square root of -1. If you recognize immediately that square root of 80 can also be broken into square root of 16 and 5. Of course, square root of -1. Square root of 16 is 4. We know square root of -1 is I, and square root of 5 is just square root of 5. So it's really good to just immediately pull out the biggest perfect square possible because you can see that it shortens the steps by half. Okay, let's take a look at B. We have square root of -10. 10 really doesn't have any perfect squares, right? 10 is just 1 times 10 and 2 times 5, and 2 and 5, those are not perfect squares. So if that's the case, there's no point of breaking it into square root of 2, square root of 5. So I'm just going to keep the square root of 10 underneath, and the square root of -1, we're going to pull it out. Square root of 10, can't really break that down, so that's just going to stay as square root of 10. And this is I again, and again, just as, you know, the way we write it is we put the I before the square root symbol. So it's I square root of 10. You can see that 10 is still under the square root because we can't simplify that further. Let's say go look at number 3. Simplifying. And before we look at 3, let's look at complex numbers in standard form. So complex numbers are a combination of the real number, so we call this the real part, and the imaginary part. So sometimes we mix the real numbers with imaginary numbers. And for example, we might have 3 plus 4i, that's a complex numbers, or 4 minus 5i, or we might have -5 plus 7i. These are all just examples of complex numbers in standard form where you have the real part first, and then we add on or subtract the imaginary part. Okay, so here now the example 3, simplify and express as standard form a plus bi, the real part plus the imaginary part. So we have -7 minus square root of -80 over 56. This looks a little messy again because it has, you know, imaginary numbers or negative roots, and then also has a fraction. The way we want to break this up into is we already did square root of -80, right? We broke that on where, let's see, here, right? Number 2, we know square root of -80 is 4i root 5. So had we not done that, I would have done that on the side. So from the previous problem, number 2, we know from number 2, we know that square root of -80, because we did the work already. I'm not going to do it again, right? 4i root 5. So we can rewrite this as -7 minus 4i root 5 all over 56. Now what we're going to do is we're going to split it up into 2 parts. So write this as -756 minus 4i root 5 over 56. This is something you can do with fractions when you have a common denominator. You can split it up into 2 separate fractions. We know -7 over 56. We can simplify that by dividing out a 7 and 7 from both the numerator and the denominator, which gives us -1 over 8 minus, let's see if we can divide both by 4. So divide the top by 4. We're actually dividing this by 4 and dividing this by 4. Well, 4 divided by 4 is just 1, so that becomes I root 5. And 56 divided by 4, let me see, putting in the calculator, we get 14. And so this is the standard form right here, -1 over 8 minus I root 5 over 14. Here's the standard form. Okay, so we did one simplifying problem, and then number 4, we're going to subtract now 2 complex numbers. We have 2 plus 6i minus 12 minus i. We have a negative sign. We're going to make sure that that gets distributed in the second set of parentheses. The first parentheses, we don't really need to worry about distributing anything, so let's just remove the parentheses. But now we have minus 12 plus i. Now here, it's like adding like terms, right? The 2, we're going to combine it with the -12. The real parts get combined, so we get -10. And then 2i plus I, we get plus 3i. Okay, I felt like something was funny. I'm not sure why my brain just changed this to 2. Sorry about that. So let's just go back and change this to 6i plus 1i is -10 plus 7i. Okay. So that's negative 10 plus 7i. Again, sorry for that typo here, but 6i plus I, we change it to 7i. Right, number 5, we have negative 5 plus square root of negative 9 squared. Now, negative square root of negative 9, let's simplify that first. We know square root simplify. Let's spell that correctly. Square root of negative 9 is square root of 9 times square root of negative 1, which is 3i. The square root of 9 is 3. And square root of negative 1 is I. So let's just rewrite this so it's negative 5 plus 3i squared. And what that means, a square means that we have to write it out twice, right? Negative 5 plus 3i times negative 5 plus 3i, because you cannot distribute exponents. You have to write the factors out twice. Now we're going to do the FOIL process. Remember FOIL. First terms, we're going to multiply negative 5 with negative 5, get 25. Negative 5. Oops, that's the outer term. Negative 5 times 3i is negative 15i. The inside terms, 3i times negative 5 is negative 15i. And then 3i times 3i is positive 9i squared. Because 3i times 3i is 9i squared. Now the outer inside terms, both I terms, we can combine. 25, negative 15 minus 15. It's like adding two negatives together. So that's negative 30i. Be careful here that you don't automatically assume these cancel. When they're both negative, you have to add them together to get negative 30i plus 9i squared. Now from here, remember, go back. What was I squared again? We go back to, I don't know what page that was. Let's go back to the previous page. We have said I squared is negative 1. You have written that down, hopefully boxed somewhere or highlighted. So when we see or when we run into I squared, you're going to replace that with negative 1. So we have 25 minus 30 plus 9. Replace the I squared with parentheses, negative 1. You got to multiply those together. So we have 25 minus 30i minus 9. Which gives us, what's 25 minus 9? That's going to be 16. So let's write 16 minus 30i. Okay, so we did a multiplication problem. Now moving to division. But before we go into division, we have to talk about the conjugate. Now, conjugate is a term we don't use very much, right? It just means that when you have a conjugate of a plus bi, it's a minus bi, or vice versa. If you have a minus bi, its conjugate is a plus bi. Why do we need to know the conjugate? We need to know the conjugate of the denominator when we divide complex numbers. So, for example, if we had a 7 minus 2i, its conjugate is 7 plus 2i. Okay, so notice how these are conjugates. The only difference is, right, the sign change between the real part and the imaginary part. So if we take a look at this division problem, now it says divide and express and result in standard form, but we don't really divide. So it's kind of misleading. You're actually going to multiply by the conjugate. So whenever you see the word divide, think. Tip, multiply by the conjugate of the denominator. And what is the conjugate of the denominator? Well, in this case, it's 2 minus 5i, and its conjugate is 2 plus 5i. So what are we going to do? We're going to multiply the top and the bottom by 2 plus 5i. So the numerator gets multiplied. Let me just put parentheses around that. The 2 minus 5i, the denominator gets multiplied by its conjugate 2 plus 5i. You have to do the same thing to the top and the bottom to make the fraction equivalent. Okay, now what are we going to do? Well, we're going to FOIL like crazy, the top and the bottom. So the part we're going to do FOIL. So 7 times 2, right? We're going to multiply the top part. Well, maybe I should write it here. So let's do the numerator and then we'll worry about the denominator next. So 7 plus 4i, 2 plus 5i, the numerator part. We do the FOIL. So we did 7 times 2, which is 14. 7 times 5i, which is 35i. 4i times 2 is positive 8i, and then 4i times 5i is 20i squared. Well, we know I squared is -1, so that becomes 20 times -1, which becomes 14 plus, let's add the like terms, 35i rather, plus 8i is 43i. And we know 20 times -1 is -20. So the top part simplifies to -6 plus 43i. Now that was just the numerator. We're now going to do the denominator. So 2 minus 5i times 2 plus 5i, that's the denominator, is, let me write a line underneath, it's going to be 4 plus the outer is 10i, the insides are minus 10i. Oops, where did that 5 come from? Minus 10i, and then the last part's -5i times 5i is -25i squared. Now look what happens here. The positive 10i and negative 10i cancel out. This I squared is -1. So what that is becomes 4 minus 25, -1. And we know -5 or -25 times -1 is going to be plus 25. 4 plus 25 give us 29. And that's why we multiply the conjugate. Multiplying by the conjugate allows the cancellation of the imaginary terms. So we're only left with number. And now what we do is separate it into the complex number, the real part. So we're going to write it as -6. I'll write it here. -6 over 29 plus 43i over 29. And that is the simplified answers. I don't think we can simplify 6 over 29 further, or 43 over 25. Okay, so if you know, instead of doing foiling, if we know, this is one of the expressions where if you did a plus bi times a minus bi gives you a squared minus b squared. So if you know that, 2 minus 5i, then 2 plus 5i, actually, let me write that again. It's going to be a minus bi squared, I should say. And what that's equal to is a squared minus b squared, which is I squared, which is equal to a squared minus b squared. And this is -1, so plus b squared. And so that, if you know that, then 2 minus 5i times 2 plus 5i, that's always going to end up as 2 plus 5 or 20, 2 squared plus 5 squared, which is 4 plus 25. So that's another shortcut. But if that, you kind of don't like using that formula, you can always stick to the FOIL method, although it's a little longer than recognizing the formula. Okay, so that was number 6. And let's see what's next. Okay, I'm sorry, I'm looking over the answers again just to make sure I don't have any typos. I think my brain is doing crazy things. I don't know why that changed to 25. That should be 29. Yeah, you just have to make sure that when you do the work, you can see here, just go back and then look over your work to see if you didn't do anything silly, like change numbers around in your head. Okay, so it's -6 over 29 plus 43i over 29. All right. We have additional problems for practice. So here we have 4 extra problems, simplifying 4 root -4 plus 5 root -64. And then number 8 is -5 minus root -32 over 60. We have a multiplication problem, 5 plus 9i, 5 minus 9i, and divide 6i over 3 minus 2i. Now I don't provide you the work, but here are the answers. 7 should be 48i. 8 should be -1 over 12 minus I root 2 over 15. 9 is 106. 10 is -12 over 13 plus 18 over 13i. I would like you to try these problems on your own just to make sure you understand the concepts from this section. Okay, if you have questions at any time, you know how to reach me. Just don't hesitate to reach out if you have concerns, questions, or issues. Okay, I'll see you in the next video.